after performing this Pass1, we will be generating an intermediate file, and the intermediate file will be in this format. Okay, we will be having an address, and then we will be having a label, opcode, and the operand field. Object code, it will be generated only in the second pass. So after Pass1, intermediate file will be generated, and intermediate file will be having this much contents. Then object code will be following the format like this. It will be having a header record, text record, and end record. Header record, it will be starting with the header H, and followed with the program name, and 8 to 13, that columns, it indicates the starting address, and then comes the length of the object program in bytes. How the length of the object program will be obtained? That is the length of the program based on the location counter value and the starting address. While it encounters the end directive, what is the location counter value minus the starting address of the program generates the length of the program. So header record, this is the header record, H followed with name of the program. So here some spaces is left in between, isn't it? So it shows that 2 to 7 columns, 2 to 7. 6 columns are there to store the program name. So copy will be having only 4, it occupies the 4 columns, and the remaining 2 columns will be left as such. And then 8 to 13. Again 6 columns, it will be used to store the starting address of the object program. So here the starting address is 1000, so here it is stored as 1000. And then 14 to 19, it indicates the length of the object program in bytes, and length of the object program, it can be found by subtracting the current LOCCTR value with the starting address. They will be getting as 1079. Okay, so in this case 107, towards the end you need to write, and the first first locations will be made as 0. You need to occupy the last bits. Similar is the case with the text record also. First column, it indicates the text T and starting address of the object code. So object code starting address will be mentioned in the 2 to 7. Length of the object code in the form of bytes 8 and 9th column will be written. Object code will be represented in X. 2 columns per byte. 2 columns per byte. So 10 to 69 columns, it will be treated as the one object code. So if the size exceeds this 69 column, then again it creates the next text record. Okay, so text record, it starts with the starting address 1000, it will be given, and the maximum length of one text record will be 1E. 1E will be the maximum size of one text record. So the address object code generated for each instruction will be written here. So first instruction object code will be 141033, it is written here. Second object code is 482039. So 482039 is written here. Okay. Similarly, each instruction object code will be written till its size is 1E. If it exceeds that size, we need to create the next text record. So each text record will be of size 1E. Okay. Then end record will be like column 1 will be E, column 2 to 7, address of the first executable instruction in the object role, that is hex. So in text record also, the next after 1A records, 1A length records after storing as one text record, the next text record will be having a starting address, that is 101. That is the next address of the instruction. That will be the starting address of the next text record. Similar will be the case for the the later text records also. For end record, the syntax is E will be given and then the starting address of the program. Address of the first executable instruction in the object program, that is 1000. So in intermediate file also you will be writing the first executable instruction name, that is first. So the address that is allotted to the first will be given in the object program. Okay. So this is the case with the object code representation. So how this object code is being generated? It is generated in Pass2. So Pass2 is like again input given for the Pass2 is the intermediate file. So in the intermediate file it checks whether the opcode is having start, then it indicates the starting address. So starting of the program, so you need to write the first line. First line is the header record. So header record, how you will be writing H followed with copy name. Copy, that is the name of the program, that is comes in the first line itself. So if the opcode is start, you need to put H, then copy, you need to, name of the program will be included, and then the starting address, then length of the program. These things will be written. That is a right header record to the object program. If it is not equal to start, means it checks for the opcode whether it is not equal to end. It checks for other opcodes. It searches the opcodes in the op tab whether the opcode is a valid. It will be a valid one because it has passed the Pass1 algorithm also. So in that op tab, if it found the opcode, means it checks whether there is any symbol in the operand field. Symbol in the operand field. Then if there is any symbol in the operand field, then it checks for the symbol in the sim tab. And if any symbol is found, it takes the operand address. Operand address. And if no symbol is found, what it does, it stores 0 as the operand address. So first, if start is found, means you need to write the header record of the object program, write the name of the program, starting address, and the length of the program. You need to write it. Then if the opcode is not start, it checks for other opcode, and if it is not equal to end, it searches for the opcode in the op tab. And if opcode is found in the op tab, it checks the operand field. And if there is any symbol in the operand field, it checks whether that symbol is found in the sim tab. And if that symbol is found, then it takes the operand address. Sim tab will be having a symbol and the address value. So it takes the operand address. If no symbol is found, then what it does, it instead of taking the address from the sim tab, it just store 0 in place of the address, and it will be setting an error flag, which will be some undefined symbol. Okay, which means it needs to, some address is not filled for that operand. Again, if the opcode found is equal to byte or word. If the opcode found is equal to byte or word, convert the constant to the object code. If the opcode that is found is a byte or word, this byte and word, they are the assembler directives. So it won't be translated to its machine equivalent. Instead, it considers the operand value, and if the operand if there is any operand value, then that operand value is converted to its object code. If object code will not fit into the current text record, so as said earlier, there is a maximum size for each text record, that is 1E. And if the object code of the text record it exceeds 1E, then the current text record will be stopped and continues with the next text record, inserting the starting address of the text record as the next instruction starting address. So that is the algorithm, that is the statement that is given here. If the object code that is not fit to the current text record, then write text record to the object program, initialize the new text record, add object code to the text record, write the listing line, read next input line. So this proceeds until it reaches the end. When end directive is encountered, it exits from this loop. Write the last text record to the object program. What is the last text record? That is read before this end directive is encountered. So that record will be written to the object program, and then write the end record to the object program. End record is E followed with the executable instruction, first executable address of the instruction. So this is the Pass2. After performing this, you will be getting the object program like this. This is the object program that is generated after performing Pass1 and Pass2. Thank you.